What's good, team? Welcome to another Small James coding tutorial where today we're going to be looking at React 18, all of the great changes that come with it, and we're going to be putting them into practice, learning them by building a pretty simple application that really demonstrates all of the key features and functionalities that come with React 18. There's some brilliant changes and upgrades from the previous versions of React, so it's definitely worth learning and integrating into any future projects that you put together. Pretty simple application we're going to be building to put all this tech to good use. It's going to be a little front-end project that uses the Pokemon API to pull in a list of Pokemon. We're going to use the error boundary component and the suspense components for better API calls and fetch logic. If I refresh this page with some throttled networking speed, we can see that we get a nice loading state before our component renders the data on the page. If we click on a Pokemon, we get the loading state once again. We get brought through to a secondary page where we have all the stats and the types for the Pokemon plus an image. We can come back to the main page. If we ever happen to throw an error, our error boundary component catches that nicely for us. We also have a nice little search bar where we can search for a Pokemon in our list. Once again, click on it, we get that loading state, render all the information. And finally, we also use a local storage cache so that we don't overwhelm the API with networking requests every time we refresh the page. So we pull the data once, we save it to our cache, and then it's instantaneous loads the next time. And obviously all of this is done within the React 18 ecosystem. So yeah, it's a pretty cool little project to add to your portfolio. It's by no means fully comprehensive, but it teaches and demonstrates all of the key features and upgrades that come with React 18. If you enjoyed the video, don't forget to like and sub. It helps me make heaps more videos like this, and let's dive into the code. So we're going to start off here inside of a terminal in the directory of our choosing. And we're going to type npm create v at latest, and we're going to name our project React 18 Pokemon. Hit enter. We're going to get some options that will allow us to configure this project. We're going to go down to React, hit enter, just JavaScript, and now we have a project that we can cd into. So we'll cd into React 18 Pokemon. And now we can go ahead and open that up inside of our Visual Studio Code editor. And if we come and take a look inside of the package.json, we'll see that we have React versions greater than 18. And this will allow us to use all of the critical features that we're going to be wanting to use, such as the new use hook, error boundaries, the suspense tags, and a whole lot more. So now that we're in here, we can open up a terminal inside of our Visual Studio Code editor. And we can go ahead and run npm install, and that's going to install all of the dependencies that we have in here. So that includes React and React DOM. And if we take a quick look at the directory that we have here, we see that we have an index.html. This div with the ID root is where our React project gets rendered. And if we come into the public folder, we have all of our static assets. And then the source folder has all of our CSS and JSX files. The entry point for most of our componentry is still within the app.jsx. And then the content that is within our app component just here, this main app component, gets rendered inside of that root element that we looked at before inside of this index.html. So as for files that we can ignore, it's primarily going to be this main.jsx. We can also ignore the index.html. And the files that we're going to be looking at is predominantly this app.jsx and all the componentry that we create there within. Anyway, we're going to start off by gutting this project here. So we're going to remove all of the content. We're going to remove these imports because we do not need them for the minute. So we can have a fairly blank project. We're also going to go ahead and come into our app.css just here. And we're going to select absolutely everything and clear that out. And honestly, we may as well just go ahead and delete this file too. I'm not going to worry too much about the content inside of this index.css. It's just the standard boilerplate code that comes with the Vite installation of React. And now we can go ahead and run npm run dev inside of our terminal, and that's going to load up our project on localhost 5173. And so here I've gone and rendered that out inside of a browser, and we can go ahead and check if that works by typing in, and we do in fact see some content just here. So that's all well and good. Now inside of this index.css, I actually lied a little bit. I am going to change some things. And that is predominantly getting rid of everything that's not inside of this root element. And we're quickly just going to style the body of our document. The body is going to select this body tag just here. And we just want to give this a display of flex, a flex direction of column, a gap of 14 pixels, a padding of 28 pixels, and that should just about do it. Now inside of our app component, this is where all of the magic is going to happen. And we're actually going to start off by diving directly into some of the new features that we have with React 18. And the first one is going to be Suspense. So we can import the Suspense tag from React just up the top there. And we are going to wrap our entire app inside of the Suspense tags just here. Now what the Suspense tags do is they essentially do away with all of the loading logic that we used to have to use in React. So historically, if you wanted to fetch data from an API in React, you would need a use effect block, you would need to manage a loading and data state, and you would use the use effect to check when the component mounts. Then you would fetch the data, you would set the loading state until the data is fetched, and you would likely have some conditional JSX on your page that was checking in on the loading state to see whether or not it should be rendered. Now what we can do is get rid of all of that complexity, and we can just wrap our app inside of the Suspense tags. And the Suspense tags essentially look at all of their children componentry, all of the contents that is contained within the Suspense tags, and it checks to see if any of that content is dependent on an asynchronous call. So if there is an asynchronous call, the Suspense tags will recognize that in the loading state, that will return a promise until the data is fulfilled. And obviously, if it's just a promise, we can't actually access that data. And so the Suspense tags will take what's known as a fallback, and we can just set that to a div that says loading just like that. So while there's any promises within the child JSX, this fallback will handle that loading state and render out this loading tag. We'll see how that works in a bit, but with that tag done, we're actually going to dive into the second major change, which is to do away with the antiquated error states that we also used to have to manage inside of our React components. So in addition to having a loading and data state, we would often have an error state that checks to see if any of our data fetching either failed or was unresolved, and if it was, it would display the loading state. Instead, what we're going to do to manage this behavior is wrap our Suspense tags and our entire application inside of an error boundary. So inside of our directories just here, we're going to go ahead and create a new file, and that is going to be known as errorboundary.jsx. Now this component is more of a class than a functional component, and so we're going to start off by importing React from React, and here we're going to say class errorboundary extends react.component, and then we're going to use the curly braces and open that up, and inside here is where we're going to define the error handling or the error boundaries that we're going to wrap our app inside of. The first thing we're going to do is manage a state. So we'll define the state just here, and that's going to have a property that has error, and we're going to set that to false. The second thing we're going to do is type static get derived state from error, and that is going to take an error. And this is going to essentially catch any errors in our component. And if we find them, we're going to return has error is true. So in the case where we encounter an error inside of our application, we'll set this property to true. And then the last thing we're going to do is call the render method. And this is going to determine what gets rendered onto our page. And so we're going to say if this dot state, so we're going to access the state within this class dot has error. If it's true, then we're going to return this dot props dot fallback. So that's going to be a fallback attribute that we're going to assign to it soon, or even better, a prop. And if that's not the case, then we're going to return this dot props dot children, which is the contents that is wrapped within the tags. Finally, inside of this component, we can say export default error boundary, just like that. Save that component, and now we can come into our app.jsx and just wrap our entire component inside of this error boundary. And with these two tags in this component, we now have a very secure and safe app that is by default going to handle all loading and error states, and it's just absolutely phenomenal. It's really sleek, concise, comprehensive, and secure. The last thing we have to do is make sure we provide that fallback prop to the error boundary component. So just in here, we can do the same thing as we did below. We can create a div and just say error ... And the one other thing we're going to do inside of our error boundary is add a method. We're going to say component did catch error and info. So in the case that we encounter an error, we're just going to console.log the error and info. So if we have an error inside of our children content, we return the fallback. Our app is safe, it will not just break, and we will console.log that error so that we can go and resolve it. So now that we have a secure app, we can start to look at the third amazing feature that comes with React 18, and that is the use hook. So as I mentioned before, if we were going to fetch data from an API, we'd typically manage 3 states: the data, loading, and error state. So obviously we have to use a whole lot of state, and we would also have to use a use effect where we define a function within that use effect to go and fetch the data. Now it's infinitely easier. We can just say const data is equal to use, and we can call a function that is fetch data, and we can pass in a URL. Now currently this component doesn't exist, and we're actually not going to use this logic inside of this component. Instead, what we're going to do is start creating the children components. So we're going to come over to our directory, create a new folder called components, and inside of here we're going to create 2 new components. One is going to be called Pokemon card.jsx. In here we can type RFC to get some boilerplate code for a default functional component, so that's nice. And then the other one is going to be called Pokemon grid.jsx, and we're going to do the same thing there, RFC. Make sure we export that component as well. And inside of our app, we can now have some conditional logic that says Pokemon selected. Well, actually, let's just say selected Pokemon. Then we use the ternary operator. And if it's true, we render out the Pokemon card. Close that. And if it's not true, so we separate the truth output from the false output using the semicolon. And in here, we just say Pokemon grid. We have to make sure that both these components get imported into this app just above. And what we're going to do is just swap the state here to say selected Pokemon and set selected Pokemon. And we're going to set the default to null. So the default state is null. So essentially how this works, we can actually see that we render Pokemon grid on our screen. And this conditional logic just here wrapped inside of the curly parentheses, because it's JavaScript operators, basically checks to see if selected Pokemon is true. If it is, it means that we've selected a Pokemon from our grid of Pokemon, and we want to fetch the data specifically for that Pokemon, including the image and some other information. If it's not set and it's null, that means that we haven't selected a Pokemon, and so we want to render out the grid, which just displays all of the Pokemon. So that is really nice and easy. The next thing we're going to do is actually come into each of these components just here. The first one is going to be the Pokemon grid, and this is actually where we're going to use this use hook. So I'm going to swap that import from just up there, move it into the Pokemon grid, and we can just say after this React import use. And as I mentioned before, we no longer need to manage a whole lot of state to access our data. We can now just say const data is equal to use and pass in a fetch data hook that has a URL. Now the URL for this particular project is going to be as follows. We're actually not going to dive straight into the Pokemon URL in case we make a mistake, and we don't want them to ban our IP address in case we do something wrong. So we're going to come over to JSON placeholder API first, just because it's incredibly simple for testing our API. And in here, what we're going to do is copy this URL and paste that into our project. And now what we have to do is we have to define this fetch data function right here. And we're going to do this up the top. It's going to be asynchronous because we have to send an asynchronous fetch request or network request to get this information. So we're going to have an asynchronous function called fetch data that's going to receive a URL. And in here, what we're going to do is we're going to say const response is equal to await fetch. We're going to use the fetch API, and we're just going to pass in the URL. Now, the critical part of this function just here is that it has to return the promise. So instead of saying const data is equal to await res.json, now what we do is we remove the await keyword and we just return res.json just like that, making sure that we have the circular parentheses after the JSON so that it's a method. Now, until this is resolved, this is going to return a promise of information. So when we go to call data, and what we could do is we could render out data just here. I know that this particular data returns a title property, so we could just render that, for example. Until this promise is resolved, we are going to actually have a promise, and these suspense tags that we've wrapped this component in are going to recognize that we're trying to access data from a promise, and they're going to render out the fallback instead of the actual app. As soon as the promise is resolved, we will render out the actual information. So that is going to handle our loading state. So we should be able to actually go ahead and test this. If I save this component, we see that we actually get an error, and that is excellent because that actually just goes to show that our error boundary is working perfectly. If we come into our inspect or our developer tools, we should be able to console what the issue is. Use is not a function. And we can go ahead and resolve this problem by just typing into our terminal just here. Soon this will be available within the actual versions of React, but here we're just going to install React Experimental. So we're just going to say npm I react at experimental and react-dom at experimental. Install both of these, and we'll see that inside of our package.json, they are updated to the experimental modes. And now if we go ahead and restart our application, just in here, npm run dev, we reload the page and we see that we actually get some data back from that call. So that's excellent. If we look at our network tab just here, we can see that we do make an API call to that API, JSON placeholder 200 response. We no longer render out the error boundary. And if I refresh this page, we can see the loading flash just there. If I throttle this networking request or this networking speed to a fast 3G, we see that after our React project loads, we execute the fetch request, we get that loading state, and then we get our data back. So it's unbelievably easy to access data or fetch data in this experimental or new version of React using the use hook in combination with the suspense and error boundary tags to wrap our application. So now that that's working, the next thing we're actually going to do is call this hook inside of some conditional logic, which is another thing that we never used to be able to do in previous versions of React. And the way that that's going to work is we're going to say if local storage, so we're going to cache the data inside of the local storage so that we don't overwhelm this API or any API with network requests. If local storage.get item, we're going to look for the item associated with the key Pokemon cards. If it exists, then we're just going to say data is equal to local storage.get item, the exact key that we got here, because we've already made this call, so we can just access it from our cache instead of calling the API again. Up here, what we're going to do is just initialize data. And if it doesn't exist inside of our local storage, then we can use this fetch hook inside of this conditional logic. So it's super easy. And the last thing we'll just do is we will write local storage. We'll set the item equal to Pokemon cards. And we'll make sure that we say JSON.stringify and pass in the data. Up here, the other thing we'll actually have to do is just make sure we pass this stringified JSON. And so with this caching, we should actually be able to see just here if I console.log fetched from API. And then up here, we're going to duplicate that and just say fetched from cache. We should see that when I reload this page, we console.log fetched from API. So that works perfectly. Now, if I remove that throttling and come back into our console, reload the page, we get an issue. And that's because local storage.get doesn't exist. And that's where I made the mistake. It should be get item. But we can see that we're actually inside this code block just here. So the key does exist and we fetched from the cache. This is going to make our application unbelievably quick, and we're going to avoid unnecessary networking calls. So it's going to be brilliant for the API. And now what we can do is actually come over to the Pokemon API. It's Poke API. The links for all of this stuff will be in the description down below, so check them out if you want them. Same for React Experimental. And what we can do is we can come to the documentation. And once we're in here, we come down to Pokemon just like that. And here it says that we can specify a name or ID, but if we just don't specify one, that's actually going to just send the network request and give back all of the Pokemon. So just in here, what we can do is we can update this URL. We're also going to have to come in and clear our cache, because if we reload our page, we can see that we're still fetching from the cache. So we're going to come inside of our application just here, click on local storage, and we are going to come over. We can see that we have that cached information. We're going to delete that so that doesn't exist. And now we should be able to reload our page. Let's just track our networking request so that we can see it happen. And when I refresh this page, we should get the loading and we should fetch all of the data from the new API, which is this URL just here, get back all the Pokemon. And what I'm going to do is just return data title, because the title parameter may not exist. So here we can see that that fetch request went off. We got a successful 200 response. We're not rendering anything on the page because nothing actually exists. If we come into our console, we actually fetch from the API. If we come back into the network tab and look at the response information, we can see that we have a whole heap of information just here, all the different Pokemon that we can get. So that is super cool. Bulbasaur, Ivysaur, Charmander, just like that. And what we're going to do now is actually pass this information. First, let's just see if we fetch from the cache. We do, so we're not going to overwhelm the API with API calls, and we can just actually console.log the data in here so that we can access it. We see that this is what we've got. We've got 20 results, so that's pretty cool. We're just going to start off with some basic Pokemon. We see here that they have a default offset and limit on their API calls, so you can just, update that and add pagination really easily. And what we're going to do in here is just map out some content. So the first thing I'm going to do is define a class name. We're going to create a modular CSS sheet. So that's going to be Pokemon grid.module.css. The modular sheet or the modular key just ensures that the CSS styles in here are going to be scoped specifically to this component. I'm going to define a Pokemon grid style. We're going to give this a display of flex. We'll say flex direction of column. We'll say a gap of maybe 8 pixels, nothing complicated. And we're going to give it a margin of 0 and auto so that it self-centers its page, so that it centers itself in the middle of the page. We'll give it a width of 100% of the parent element, but we'll also give it a maximum width of maybe 800 pixels so that it's approximately a prose width. Now inside of our component, just here, what we can do is we can render out this class name. But first we have to make sure we import it into our component. And so we can say import styles from ./Pokemon grid.module.css. I'm actually going to go ahead and rename it with a lowercase p because only the components need to start with the capital letter. So that's going to import styles, and now what we can do is access that styles object just down here and assign the Pokemon grid style. So that's going to create a grid in the middle of our page. We should be able to see if that's working by typing something in here. So I could just type hello. And now if I come back in here, we would expect that to self-center, and it does in approximately 800 pixels. So if we look at that element, we should be able to see inside of the body, inside of the root, we have our app, and then we have our Pokemon grid, and the Pokemon grid is only occupying 800 pixels. We can see that width just there. So that's working well. The next thing we're going to do just in here is create an h1 tag, and this is going to be h1, and we're just going to say my Pokemon. That's just going to be nice and big. And now that we have my Pokemon rendered out on our screen, the next thing we're going to do is have a div. And inside of this div, we're going to give this a class name equal to styles.listContainer. And inside of our modular CSS sheet, we can just target that list container. We can give it a background of green. We'll see if it's working just like that. And inside of here, I'll just say that, refresh that page, and that's not working. And the reason that's actually not working is because we have a spelling error inside of our CSS sheet. I would definitely recommend that you use all lowercase in your CSS sheet. So now that actually does work. And while we're in here, I'm just going to create one other style that's .header. And I'm going to apply this to this h1 here. I give this a class name equals styles.header. So now we have a header. We can give that a text align of center. So the my Pokemon is centered. We have this little container right here. That works. We'll give this a display of flex, a flex direction of column, and maybe a gap of 10 pixels. So that should be pretty easy. Now if we come onto a small page, it's all centered and responsive, and then up here it should just stay in the middle of our screen, which it does. So for our list, we're going to come into our grid, and the first thing we're going to do is define an input, and this is going to have a placeholder value equal to search Pokemon. We're going to close that and give it a value equal to search, and an on change is going to take the event as an argument and set search equal to e.target.value, just like that. And then up here inside at the top of our Pokemon grid component, we're going to define const search set search is equal to use state and give it a default state of an empty string. Up the top of our component, we'll have to make sure we import that state. And now we have this little search bar just here where we can search for Pokemon. Underneath this input, what we're going to do is use some curly parentheses to map out some content. So if we take a look at data, we can see that data is equal to results, which contains an array of all of our Pokemon. And so in here, what we're going to do is we're just going to say data.results.map. We're going to say Pokemon index, return an arrow function, and from the arrow function we're going to return some JSX. We have to make sure that we give it a unique key that's going to be Pokemon index so that React can track the list. And in here what we can do is we can render out Pokemon, and if we take a look at the results in here, we can see that we can access the name parameter, and now we have all of our Pokemon. So after that, what we're going to do is we can actually use this search input, but we're going to actually chuck in a little filter just here. We'll take the value, open that up onto a new line, and we'll turn results, and we want to check if the value includes the current search input. So that broke our little component. If we come down here, we can see that val.includes is not a function, and that's because it should be val.name if we recall. And now what we can do is we can search for Bulbasaur, and it's just going to filter through those entries on our screen. So the next thing we're going to do is give this little element a class just here. That's going to be styles.pokemon, and we can come into our Pokemon grid.module.css, target it, and we're just going to say transition duration of 200 milliseconds, a cursor of pointer, and we're going to say .pokemon hover will provide a hover state, and we'll just say padding left of 4 pixels. So what that's going to look like is whenever we hover over it, it's just going to pop out a little bit. If I remove the search, we just get that little list. And what we're also going to do is we're going to say on click, and we're going to define a function up here, which just says handle select Pokemon. And this is just going to actually need to be defined inside of our parent component. So if we come up to our app, we can define this Pokemon here, handle selected Pokemon. That's going to take a Pokemon, and we're just going to return a curried function that says set selected Pokemon equal to Pokemon. So now what we can do is we can pass this function down to our component, our Pokemon grid, as a prop. And inside of our component, we can receive the props, and we can actually destructure that function from the props. So now we're communicating information down throughout our components. And finally, what we can do is we can assign or call this function just here. We can pass in the Pokemon as an argument. And now what will happen is we will be able to select a Pokemon and set that state. And you can see that we actually render out the Pokemon card. And if we come into our app and we pass down the Pokemon or the selected Pokemon just here to this component, we can say selected Pokemon is equal to selected Pokemon, and we'll also pass down the method. Or even better, we can redefine one. So we'll say clear handler is equal to an arrow function that just says set selected Pokemon null. So inside of our Pokemon card, we can come in here and we can receive the props. We can destructure selected Pokemon. From the props, we can also destructure our function, and we can say is equal to props. Save our app component, and now what we should be able to do is inside of our Pokemon card, we should be able to render out the selected Pokemon just here inside of an H1. So we can say Pokemon. And so if we come into our application and click on a Pokemon, we get an error, and that's because what we're doing is in our Pokemon grid, we are setting the Pokemon, which is an object, whereas we actually want to set the Pokemon.name. So if we just refresh that page and try it again, we can see that Bulbasaur now appears. And what I'm going to do is inside of this Pokemon card, I'm going to open that up onto a new line. We're going to create a new file, and it's going to be called PokemonCard.module.css, all lowercase. We're going to say .card, and we're going to give it a max width of 1000 pixels. We're going to give it a width of 100% of the parent element and a margin of 0 and auto. We're going to give it a display of flex, a flex direction of column, and a gap of 20 pixels. And then in here, what we're going to do is we are going to wrap this inside of an h4 tag, just so that the Pokemon is nice and big. We're going to wrap this h4 inside of a div, and we're going to give this element a class name of styles.card. We're going to import the styles, so import styles from Pokemon, /Pokemon card.module.css, and then we can give this one a class name equal to styles.header bar. We'll quickly come in here and make that. We'll make .header bar. We'll give it display of flex, align items of center, and a justify content space between. And then in here, what we're going to do is we're just going to have a div, and that's going to have a little X that we can click. So there's our X, and the X is going to have an on click, and that's just going to say clear handler. So if we click that, that should take us back, and it totally does. So that's just, simple and neat. And then in here, we're actually going to do a similar thing. So we're going to import the use hook. We're going to have another function. So we're going to just come up here, copy this fetch data function. We'll paste that up here. In this case, it's actually going to be a slightly different URL. So we can take the parent URL and we can say const Pokemon URL is equal to parent URL plus Pokemon, or selected Pokemon in this instance. If we go into our app, we can see that our base URL is actually in this Pokemon grid component. So I'm just going to pass it down here too. And that way it can sit in the parent component. Let's just come back across here, the parent component, and we can have the URL, that's the base URL, and we can pass that down to both of them. So I think in this one, it's going to be parent URL is equal to URL, and then this one is just going to be URL is equal to URL. So now we can access that in both the children components. That one already had a slash, so we actually don't need to add that. And now we have the Pokemon URL, and if we console.log Pokemon URL and refresh that, and then click on a Pokemon, we can see that we get the URL right there. So we should be able to call the fetch data function. So we can say const data is equal to fetch data and pass in the Pokemon URL, and we can console.log data and see what we get back. We can see that that is a promise, and that is just happening because I forgot to put it inside of our use hook. Have to make sure we do that. And now if I click on Pokemon, we get the information specific to that Pokemon when I click on it. And so what we could do in here, I think we're going to render out the image. So here we have all of the images inside of sprites, and then we can just render out the rest of the information. So we've got a whole lot of moves, stuff like that. We might just go with the stats and the types. So what we can do down here is we can have an image that can have a source equal to data.sprites. Let's take front underscore default, and we can give it an alt is equal to the selected Pokemon. Close that. Let's see what that image looks like. Renders out little Bulbasaur for us. That's super adorable. And then underneath that, what we can do is we can say object.keys data, so we can get all of the different keys. Well, actually, no, I retract that statement. Let's just have an H5 just here that says stats. Under this, we can map out all of the stats. So if we look at what they are, stats is different types of information. So we can map out all of the stats. So we'll say data.stats.map. We'll say stat and stat index. Open that up and return a div with a key equal to the stat index. Close that div, and in here what we can do is we can just have a paragraph that has a bold tag around the stat. So that's going to let us know what the stat is. And in this case, the stats is going to have to access a stat.name. I think that should do it. And then after here, what we can do is we can access the value, which is going to be the base stat. So it's going to be stat.stat.base stat. It's a lot of stats, but let's see if that worked. So here we have all the stats, so that totally worked. I might actually make this an H3 and possibly this an H1, just so we get some slightly different sizes going on. So stats, we have all the different stats. The base stat didn't work, and that's because I added one too many stats. So if I do that, we can see that we have the HP, attack, defense, all that good stuff. So that is super neat. I might come back into the Pokemon card and bring this gap down to 4 pixels because it just doesn't need to be that big. We click on Ivysaur, we load Ivysaur's data. We see that the loading actually works for that too, so that is awesome. And then underneath this Pokemon card, we're just going to go ahead and have another H3, and this is going to say types. And then we're just going to have a very similar code block where we access the types of the Pokemon. So that is just going to be .types. And in here, it's going to be type.name. So we can say type index. Swap out this index, and in here we can say type.name, and then this can be, we don't actually need a value for that. Let's see if that worked. So there we have the stats, and then we have the types. So that is just, super neat and tidy. Obviously you could display more information if you wanted to, but we're just making a very simple application to demonstrate the capabilities of this technology. Now it looks like our card style didn't work 100%, so let's try bring this down to 700 pixels, and there you go, it's actually working. It's centering Ivysaur in the middle of the page, and then we have all the stats for everything. And honestly, that's pretty much the whole application. Super simple, very clean and concise code. Looks infinitely better than the antiquated practices for loading data, fetching data from an API, and all of that syntax that we used to have. The use hook, the suspense tags, and the error boundary wrapper handle all of our applications for us. We can see in here that if I just added 3 things, we get the error component displaying perfectly. So, it's really just super convenient in the way that it works. We can fetch Weedle. Weedle's information comes through. Cute little Pokemon viewer. Very simple. And yeah, that's pretty much the whole video. If you've enjoyed the video, don't forget to like and sub. It's super appreciated, helps the channel grow, helps me make more of these videos. Thank you so much for watching, and I will catch you guys in the next one. Peace.